after that, we have coil in changing magnetic field. Okay,
Yes, ma'am.
let's have a look over that. Coil in changing magnetic field. So basically what happens is a magnet is moved towards the coil, okay, and it is moved away from the coil. Let me show you in the diagram that thing.
Yes, ma'am.
Okay, check this picture. So here one magnet is inserted in the coil, and to oppose the magnet come into the coil's magnetic field must push it into. Okay, so the direction of the current is found using the grip rule. And how it has been found? The grip rule says if the current is moving along the thumb, then the curl of the fingers will give you direction of magnetic field around it. Done?
Yes.
So here, applying the Faraday's law as the magnet approaches the coil. Okay, Akshita, the magnetic field inside the coil increases, correct?
Yes, ma'am.
Okay, and the changing magnetic flux enclosed in the coil also induces EMF in the coil, and basically that will start causing a current to the flow.
Yes, ma'am.
This is coming towards it, so magnetic field lines will move into it. Done?
Yes, ma'am.
So that means field is increasing inside the coil.
Yes, ma'am.
The number of field lines passing through it at 90 degree, that is magnetic flux, will induce an EMF in the coil. That here suppose all the plus charges, here suppose all the minus charges will assemble.
Yes, ma'am.
Okay, any doubts still here?
No, ma'am.
Okay. Now as the number of charges gets assembled, what will happen is the current will start flowing from plus to minus.
Yes, ma'am.
As soon you will take it out, at that time also the current will flow, but now in opposite direction.
Yes, ma'am.
Now let's apply the Lenz's law also over here. So applying the Lenz's law, the direction of induced current will be such that it opposes the change producing it. Correct?
Yes, yes, ma'am.
The direction of induced current will be such that it opposes the change produces it. So what is the change? Change is it is going inward, and hence the field is created, right?
Yes, ma'am.
Okay.
I asked for like a description, ma'am. Like a 3-line description of something to just remember it in words for last.
For example.
Yeah. This thing.
Okay. Okay, done. I'm explaining you. Let me check. So as the magnet approaches the coil, this will be the three-liner. The magnetic field inside the coil increases, and the changing flux enclosed in the coil induces the EMF in the coil. That causes the current to flow. So the size of the EMF will be equal to the rate of change of flux. Done?
Yes, ma'am.
Anything else you need?
No, ma'am.
Now this was all about how it should go. But now let's write applying the Lenz's law. Correct?
Yes, ma'am.
So what does he suggest? He suggests that
Ma'am?
yeah, I'm here. Don't worry.
Okay.
So the direction of the induced current will be such that opposes the change producing it. Done.
Yes,
So
ma'am.
in this case, the magnet moving towards the coil, so it will oppose this. So the current in the coil must induce in the magnetic field in such a way that it pushes away the magnet. This direction is as shown.
Yes, ma'am.
Okay, now let me show you the. I think I had already shown you, isn't it? Yeah, here it is. To
This
oppose
one.
the magnet coming into the coil. Yeah, here it is.
Yes, ma'am.
Check and write it up.
Okay, ma'am.
Yeah.
Yes, ma'am.
Are you done?
Yes, ma'am.
Okay. So let's move ahead now. Next one is coil in the changing field. Already we had discussed this.
Yes, ma'am.
Now if understood? Now after this we are having coil entering and leaving the magnetic field. Just listen over here.
Yes, ma'am.
Okay, what happens when the coil enters and leaves the magnetic field. So basically, when the rectangular coil is at rest and moving at a constant speed, what happens is when it moves in the magnetic field, there is no change in the magnetic flux, you will observe. Okay. Why? Because there should be some change that should occur to create the magnetic field, right?
Yes, ma'am.
Okay. But EMF is induced in the coil that leaves and enters the field. Here is the field. Here is the coil. It is coming towards, going away. Understood now?
Yes, ma'am.
Now, since the EMF is equal to rate of change of flux, your EMF will be NB del A over del T. Okay?
Yes, ma'am.
Remember this formula or not?
Yes, ma'am.
Great. So now N is the number of coil, A is the area of cross section of the coil, T is the time period in which it is traveling, and for the coil moving at speed V. This will be given by so for the coil moving at speed V perpendicular to the field, it will be given by EMF is equal to NB del
Yes, ma'am.
NB del V. Okay, because speed is basically the rate at which the length of area becomes closed. How it is traveling? It is traveling like this, no? So the velocity will be what? Distance into time. How much distance does it travel? It travels this much distance, area over time, correct?
Yes, ma'am.
Now any doubts?
No, ma'am.
No need to go much into it. You just have to remember that how much it is giving the EMF. Okay, that will come in your exam.
Yes, ma'am.
Okay, so
Yes.
basically, yeah. Perpendicular to the field. So the EMF is given by NB del P into W. Now what is W? W is the width basically through which it is coming out and going in. Okay.
Yes, ma'am.
And V is the velocity. Any doubts still here?
No, ma'am.
Okay. Now let's have a look over here. Coil which is having 50 turns. So N is how much?
50.
50. Area of cross section is 2 centimeters square. Flux density. Flux density is how much? 100 micro Tesla. What is the total flux? So how will you find the total flux? EMF is del phi over del T, correct?
Yes, ma'am.
Okay, so we will apply that formula. Fine. So it will be how much? Del phi over del t. What is del phi over del t? Del phi over del t is n into a into b. Correct?
Yes, ma'am.
Okay, so we will find out that. Okay.
Yes, ma'am.
How much it will be? 50 into 2 into 10 raised to minus 3 into 100 into 10 raised to minus 6. Please give me the answer.
Okay.
How much it is given? Centimeters? Okay, wait. Centimeters, so it will be 10 raised to minus 4. Sorry, my bad.
10, 10, 100, 6. 0.0000. 1 second. 1, 2,
1
3,
into 10 raised to minus 6.
1, 2, 3, 4, 5, 6. Yes, ma'am.
Is it
Yes, ma'am.
coming or not?
Yes, ma'am. Yes, ma'am.
Okay, now we have to find for the second, that is what is the rate of change of flux. So just do it. Del phi over del t. What will be that? In 2 seconds.
Mhm.
Flux changes 50 microtesla in 2 seconds.
Okay, ma'am.
Okay.
50 into 10 to the power minus 6.
Solve this now.
Yes, ma'am.
PAN, where you will take 50 into 10 raised to minus 6 Tesla. A is how much? 2 into 10 raised to minus 4. What is the formula given? N into P into A over T. N into P into A over T.
Divided by P, which is N, P. From 50 into 10 to the power minus 6 into 2 into 10 to
Sorry?
50 into 10 to the power minus 6 into 2 into 10 to the power minus 4 divided by T, right?
Yeah.
T is 2 how much was T, ma'am?
It is 5 into 10 raised to minus 9. Weber per second.
Oh, okay, ma'am. That's good.
Weber is the SI unit for EMF.
Yes,
So
ma'am.
it will be Weber per second. Are you done?
1 second. Is it 0.00000005?
Yeah, so I given you the answer now. 5 into 10 raised to minus 9. Is it?
I can't see it, ma'am.
Be the answer.
Yes, ma'am. Now I can see it. Before I was in, yes, ma'am, same thing. 1, 2, 3, 4, 5, 6, 7.
Next questions, please solve it at your own. Done?
If the
Yeah. I had already shared this page with you. Next
okay.
is coil rotating in a uniform magnetic field. Now check. So basically here is the coil which is rotating in a uniform magnetic field. Okay. Basically this is the generator. Check.
Yes, ma'am.
Anything that you want to understand. It's already been discussed in grade 10. Generator,
Yes,
right?
yes, ma'am.
Do you want to?
No, ma'am.
Okay. So now I can explain the diagram which can be shown, that how it is going after each half rotations. Okay, that thing I can show you, that what happens after every half turn, that it actually gives this type. Okay. So when it is going down, current is going up, here it is going down. Whereas when we move the spindle up, here the AP direction is coming down and the CD direction goes up. So it is continuously rotating inside this. Understood?
Yes, ma'am.
Okay. Now what is the size of the EMF that is induced in the rotating coil? So it will be same again. As it is having n turns, so it will be BAN cos theta. I had already explained you these things prior.
Yes, ma'am.
Okay. So the change will be BAN. Still I am writing it for you. Check. So if there are n turns, so total flux will be n phi and it will be BAN cos theta over here. Understood? I had
Yes.
told you how it passes perpendicular. Check. This is the one direction. This is the one direction. So whosoever is passing at 90 degree, that is cos theta. Okay.
Yes, ma'am.
So now after this, let's have a look over the graph, which looks something like this. You should be having a little knowledge of the graph of this if somewhere it has been asked. Check. Okay. When it is going up, it's here. When it is going horizontal, it is here. Again, it is going up, it is here. Again, it is going horizontal, it is going here. Same condition, again the crest is received. So this is basically 0 degree, that is crest. Correct or not?
Yes, ma'am.
Not 0 degree, but it is 90 degrees. Sorry. Cos 90 is 1.
Mm.
Cos 90 is how much? 0, na?
Uh, 0, 1 by 2, 1 by 2, 2, 3 by
Sin 90 is 1.
cos
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 90
0
is
is 1, cos 0 is 1, cos 90 is 0.
cos 90 is 0. Yeah. So on the origin line, 0 line, cos 90 will be here. Correct?
Yes,
This
ma'am.
will be again going down. So here it will be 0. Again going down. So it will be minus 90 degree. Okay. Again coming up 0. Again going down 90 degree. So crest, mean position, trough, mean position, crest. Understood?
Yes, ma'am.
Okay. Please compare these data that you have to write.
Yes, ma'am.
Okay. So now, what happens when you actually increase the angular velocity? Let's check.
Yes, ma'am.
First, let me explain you the ABCD position. So, it is nothing but Akshita phi equals to minus del phi over del t. Isn't it? The graph is for this.
Yes, ma'am.
Done? So, when the
Yes.
maximum flux density enclosed but the rate of changes is 0, so you will have 0 gradient here. Maximum flux is enclosed in this direction. When no flux is enclosed but the rate of flux is maximum, rate of change of flux. So this is B position. When maximum flux is enclosed but the rate of change is again 0. So this is the position. When the no flux is enclosed and the rate of maximum is positive gradient. It is going towards positive, right? At C it is
Yes.
0, at A it is 0, at B it is maximum, at D it is maximum, but at at B it is going down, at D it is going up. This is the change. Okay.
Yes, ma'am.
Lastly, at E position, again it is 0. Back to the origin position. Understood or not?
Yes, ma'am.
Sure.
Yes, ma'am.
Okay. Now let's rearrange this and put an equation of EMF, which is nothing but your E equals to E naught sine omega t, where E naught is the amplitude of the wave. E is the EMF of the wave. So check. E naught is the peak altitude. So altitude is how much? E naught sine omega t. That is sine theta. So maximum EMF is obtained when your E naught is maximum. Okay. So when the coil is taking T time to run through the angle theta, when it is traveling at this angle theta, the angular velocity will be omega. Okay, this so I hope you are aware. Theta equals to omega t. We have
Yes.
studied in angular physics, right? So what happens if I increase the particular angular velocity, that is omega. So when you increase your omega, what happens? Your theta increases, but your time period decreases. Okay. So let's do that. This is how you obtain the graph.
Yes, ma'am.
Understood?
Yes, ma'am.
Check. Any doubts?
No, ma'am.
Sure.
Yes, ma'am.
So the EMF have got increased, but the time period have got short. First the wave was here, now it is becoming exact half. Okay. Now let's come up to the next topic. Self-induction. Suppose this is a soft iron coil. One coil is winded here, one coil is winded here. Okay. This is
Yes.
primary coil, this is secondary coil. Now
Yes, ma'am.
as the current is supplied through this, okay, as the current is supplied, the current will generated over here and it will produce its own magnetic field. Hence, one pole will be north, one pole will be south. So ultimately what will happen? This will become electromagnet and it will be dragged towards this position. As it is dragging towards this position in this coil, the current will be, or the EMF will be induced. Correct?
Yes. Yes, ma'am.
Okay. Now here I am connecting a galvanometer which will detect this. As soon it is dragged over here, it will leave this position temporarily because it had attracted towards this. As it leaves this position, again the current switch off. So again it will go back. As it go back, again it is connected to the battery. Again it will get charged. Again the current is supplied. So current is coming, going, coming, going. So it is self-inducing other coil with the help of mutual induction. Okay. And
Yes.
in self-induction, what happens is the flow of current is generated in the coil, okay, and a power station will provide the current to the household, and the current itself reduces its effectiveness of the generator because the process is going under self-induction. Wait. So it is a phenomena in which the changing current in the coil induces the EMF. Okay. Check.
Yes, ma'am.
Self-induction is the phenomena in which the changing current in the coil induces EMF in the same coil, and due to which magnetic flux is generated in the coil. Okay.
Yes, ma'am.
Okay. Now let's come to what is mutual induction. So with the help of one coil, when the other coil also gets charged due to the passage of EMF. Okay.
Yes, ma'am.
Okay. Anything here that you are not getting?
No, ma'am.
Understood, no?
Yes, ma'am.
Mutual induction is the phenomena where changing current in one coil induces the EMF in the nearby coil.
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. Let's come to the next pointer. Okay. Till here you want to ask anything, you can ask now.
Uh, is this now the transformers, ma'am?
Yeah. This
Now,
is transformer. It is dependent upon mutual induction. Now next one is self-induction also.
okay.
Self-induction in which the coil actually is like this, and here the rod is there. It gets what happens is the change in the current in the coil when we are passing the current on and off situation. Okay, it's getting on, so the current will pass. This will become magnet. Hence, it will pass the magnetic field through it. As the magnetic field is passed, what will happen? It will interact again with the coil current. Hence, it will get induced EMF.
Yes, ma'am.
Anything you want to ask?
No, ma'am.
Sure.
Yes, ma'am.
Let me give you a diagram for this. Okay, so this one is self-induction. Understood? Check. Okay,
Yes,
as I
ma'am.
had explained over here also. Fine. Now let's start with the next topic. E1. Structure of atom. Okay, let's pay attention over this. So basically the arrangement of the charges in the atom. What happened is many theories came who had given that how the charges are arranged in the atom. Very first came is the plum pudding model. Okay, and It was given by J.J. Thomson. He said that you can compare it like a plum pudding, where the cherries give you the number of electrons, whereas the stuffed baked part will give you the number of protons.
Yes, ma'am.
That the positively charged will get more and more attracted with the electrons. Hence, there will be some spaces which will be remained vacant or empty. Hence, the plum pudding model will not have a uniform field inside. Correct? So this was
Yes,
the
ma'am.
first failure. Now the few I have to go as per syllabus, so I need to check. He said that the atom is uniform sphere. Okay, so basically the negatively charged electrons are embedded inside it, like a positive pudding is there, and the uh, cherries are playing the role of electrons. Okay, so the model did not include in the nucleus, hence it got failed. Then the total positive and negative charges are balanced, make that the atom is electrically neutral. Okay, but
Yes.
plum pudding in plum pudding model, we have electrons which are scattered inside the soft spongy pudding. Okay, so this is what Thomson has imagined. Done. So the electrons, like plums, they are floating inside the positive charges. So he is not able to explain that the result of uh, Rutherford's gold foil experiment. Also, he got failed in describing the nucleus and the atomic structure of the atom. Done.
Yes, ma'am.
Okay. You want to ask anything? You want to write it?
Yes, ma'am.
Wait, let me give you. But you will make it very fast, okay?
Okay, ma'am.
Just wait. Check here. So basically, it was J.J. Thomson who had actually worked with this theory. And the electron is a small negative particle for him. Okay, Thomson realized that the electrons were very small in comparison to the whole atom. He therefore proposed arrangement of the charges. Okay, and he had compared it with the Plum model. Done. But what were the
Yes, ma'am.
limitations of this? That he
This is
was
not
not.
correct.
Yeah, actually, this is not correct. No, I had given you 2, 3 reasons. You can write them.
Yes, ma'am.
Check. He could not explain the result of Rutherford gold foil experiment. Okay. He is failed to describe the nucleus, atomic structure, and alpha scattering experiment. Okay.
Yes, ma'am.
Mhm. After this, we have alpha scattering experiment. Do you know what is that?
And the particles were like sent through a sheet like a gold wrapper to that one.
Okay. It is given by whom? Rutherford. Okay.
Yes, ma'am. Gold
Yes.
foil to that one. Uh,
Yes, please explain. I'm listening.
mm, like the mm, like there was this gold foil, man, and the alpha particles was like uh, sent through the gold foil. Um,
Okay.
mm, but there would be like some error in it, like some it's like it just I just remember that it would be like reflecting back. Um,
No
I
issue. Listen over here. Here we have one electron gun which shoots the electron. Okay.
yes,
These electron passes through the gold foil, which is
yes,
1,000 atoms thick.
yes, ma'am.
Okay. And it was gold foil because
Yes,
it
ma'am.
is carrying very heavy elements and highly interactive.
And some bounce back, some
So
reflected.
basically it is gold foil यानी कि AU. Correct.
Yes, ma'am.
Let me check. Yeah, AU is correct. So it is AU. Okay. And the mass number or the atomic number that it carries is 79. So it is 79, 158. Done. So this is the atomic number. When it shoots, what he observed is that some are passing directly, some are getting deviated, some are getting deviated, whereas some are just bouncing
Straight.
back from these thing, like exact at 180-degree bounce back. So
Yes,
the three observations he made that some space is empty, some is carrying small electrons, somewhere electrons are there that is colliding, and because it is positive in nature, so it is interacting with the negative particles and it is getting deviated from the track. Whereas the center part is containing, which is having very heavy mass and containing positive charge, 10 raised to minus 15 meters. Nearly. Okay. Because if it collides with this, it is exactly bouncing back. There is something which is very heavy in nature and carrying the same charge. And hence it is providing a repelling force to the atoms which are colliding with this. Okay. Please do write these three scenarios. Be quick.
yes,
These are known as postulates of experiment. So let me give you the diagram of this. Check. This is the diagram for this.
Yes, ma'am.
Yeah. Be quick. Write the observations.
Okay, ma'am. Yes, ma'am. Ma'am? Hello, ma'am? Hello, ma'am?
Yes, Akshita, what you have written?
I have written that like some alpha particles, they straight away entered the gold foil. Some had like
Okay.
deflected angles,
Okay.
and some had small angles. And the other one was third one. What was the third one, ma'am?
I'm writing here. See, these are the observations.
Okay.
Kindly be quick, Akshita.
Yes, ma'am.
And hence we will get the three postulates based over this. Atom consists of tiny, dense, positively charged nucleus at its center. Electrons revolve around the nucleus in the orbit like planets. Most of the atom's volume is empty space. Okay?
Yes, ma'am.
Kindly be quick. Now, after this, we are having
I think the observation and the third one and the postulate of the first one is same, ma'am.
Postulate is different and observation is different. What he observed, what he made the conclusion.
Yes, ma'am. Like the kind of like a few bounce back, revealing a tiny, dense, positive charge nucleus.
Yeah, exactly. So this is the justification for this, na? That
Okay.
some were deflected at small angles. Sorry, most alpha particles, a few bounced back, revealing a tiny, dense, positively charged nucleus at the atom center, which concluded that an atom consists of a tiny, dense, positively charged nucleus at its center. Understood?
Yes, ma'am.
Now, this thing also again is a very basic knowledge. What is the particular charge and mass? So let's have a look over this part also.
Yes, ma'am.
Are you done?
Last part, ma'am. 1 second.
Okay.
Yes, ma'am.
Are you done?
Yes, ma'am.
Okay, now check what is charge and mass. This is again a very basic knowledge. What is the mass found in proton and an electron? Okay. Then what are it says? So basically, proton and neutron have this much mass in kgs in AMU and the charge is this much. Also, what are nucleus? Particles consisting of protons and neutrons that is inside the nucleus. Combination is also called nuclide. So three numbers are there, A, Z, N. What is A? Proton and neutron. Z is number of proton. Neutron number is A minus Z. Okay. So from this we can conclude that any element can be written like this. A, Z. Okay. So what are isotopes? Isotopes which have same proton but different nucleon. So this will be different and this will be same. Okay. For isotopes. Any question?
No, ma'am.
Please write it down. Kindly be quick.
I know these, ma'am. Will they ask like definition for these in physics, ma'am?
Which definition?
These proton, neutron, nucleus.
Proton is a positively charged ion in which a less number of electron is found than the electrons.
Yes, ma'am. Like in the exam, will
Understood?
there be like a one marker for this?
Yeah, may come. But again, it's a very self-understood answer, no?
Yes,
Akshita,
ma'am.
that
Yes.
proton is a basically subparticle found in the atom where this thing, what should I say?
Yes.
Which is
Like
positively charged. Sorry, my bad. Okay. It is a subparticle of the atom which is positively charged. What is electron? Subparticle of the atom which is negatively charged. Okay. Yeah.
yeah.
Anything else?
No, ma'am.
Are you done, Akshita?
1 second.
Sure.
Yes, ma'am.
Okay. So this is it for the day, Akshita.
Yes, ma'am.
Let's continue the class tomorrow. Okay. Any doubts that you have from today's class, please ask. Okay, bye.
Bye, ma'am. Thank you, ma'am.
Yeah, bye.